Hello, and welcome to. We're going to spend our time today talking about the Diels-Alder reaction and just kind of introducing what the Diels-Alder reaction is. So, the Diels-Alder reaction, first of all, is the reaction of a conjugated pi system with another pi bond. Conjugated system reacting with a pi bond. Right, so we've talked about conjugated systems reacting already with things like HBr or H2SO4 and water, those kinds of things. And what we saw when we did that is that resonance plays a huge role, right? So if you have a pi system, and I'm just going to take a really simple pi system right here that has two pi bonds in it, and you react it with H plus, right? If we add H plus kind of to one side of that conjugated system, we make a carbocation, but through resonance, we can move that carbocation all the way to the other side of the conjugated system, right? And we talked a lot about, well, how do we analyze these carbocations and when do we one react over the other and all this other kind of good stuff that was on your most recent exam, talking about conjugated systems and how they kind of move electrons around, right? And so when we look at a conjugated system like this, there are four electrons here, right? There are four pi electrons within this conjugated system, but those electrons are kind of able to move throughout the system. And that's most obvious when we start to talk about resonance, right? If we make a carbocation, we can easily see how those pi electrons can move in order to kind of distribute themselves throughout the system, right? Now, so Diels-Alder said, okay, so H plus is great, we can do all that kind of stuff. But what if we take a 4 pi electron system and react it with two more pi electrons, right? Well, 2 pi electrons is just a double bond. So once again, we're going to take kind of the easiest, simplest version of this to start with, right? So let's just take a double bond between two carbons, right? So ethene, if you will. Okay? And what we're going to see is kind of the same thing happens, right? This double bond will go add to the ethene, right? And then these pi electrons, if we just left it at that one arrow, you can imagine like this carbon here is going to end up short on electrons because those electrons have left. So these pi electrons can move over, which is just what we did up here, only now I'm doing it in one step, right? The pi electrons go and get something, and then the other pi electrons move over, right? Because those electrons can move throughout the system, we do that. Now, what we've done here in the Diels-Alder reaction is we have additional pi electrons. So when these pi electrons come add in here, now these pi electrons can come react with the other part of kind of the other end of our conjugated system. And so what we've got now is we've got our conjugated system that we started with. Now the double bond is between the two middle carbons. And this carbon has reacted with the CH2 group over here, CH2. And the other CH2 has added back to the other end of the carbon. And what we've made is basically a six-membered ring. So I'm going to erase this because that's not usually how we draw carbons. But what we've made is we've made a six-membered ring with a pi bond in it. And this will always be the product of a Diels-Alder reaction. Product of Diels-Alder reaction. So the Diels-Alder reaction is when we take a conjugated system that has four pi electrons in it, and we react it with a double bond or a pi bond, right? And what we're going to get is we're going to get the six-membered ring that has a pi bond in it.